I want to determine whether f is even, odd, or neither. Right. Okay, so what I need to work out first of all is f of minus x, and what I know is if f of minus x equals f of x, and that's an even function, if f of minus x is equal to minus what f of x is, that's an odd function, and if neither of those two conditions are satisfied, then it's neither odd or even. Okay, so I'll work out f of minus x, so that's the square of minus x plus 1 on top, over minus x bracket the square of minus x plus 2. Right, square minus x is x squared plus 1 over minus x, and square of minus x is x squared plus 2. So that minus sign can come in front of the whole expression. I got minus x squared plus 1 over x bracket x squared plus 2, which is minus what f of x is. So the condition for an odd function is satisfied here, therefore f is odd. Part B. Determine f of x in partial fractions. So x squared plus 1 over x bracket x squared plus 2. So that's a constant over the linear factor. Plus, now this quadratic expression won't factorise, so it's going to go over x squared plus 2. So the power up on top has to be 1 less than the x squared. So it'll be a bx plus c on top of the quadratic expression. So I now multiply throughout by x squared plus 2. So x squared plus 1 is x bracket x squared plus 2 times this expression on the right hand side. So x squared plus 1 is right. So if I multiply this by a over x, the x's cancel. So it'll be a bracket x squared plus 2 plus, and then the x squared plus 2 will cancel, leaving me the x. So that's plus bx plus c times x. Okay, so the only thing I can make naught is by putting x equal to naught. So I put x equal to naught in. I got 1 on the left hand side. That's naught, so that's 2a plus, and if x is naught, all that expression is naught. So that tells me a is a half. Okay, I can't make the bracket naught anywhere else, so I'll pick another easy value for x. I'll pick 1. So on the left hand side I go 1 squared plus 1 is 2. 1 squared is 1 and 2 is 3, so that's 3a. Plus x is 1, so that's 1 outside the bracket. X is 1 here, so that's plus b plus c. So I know a is a half, so I can rewrite this then as 2 is equal to 3 halves plus b plus c. So take that over. So 2 take away 3 halves is 1 half. So I got b plus c equals a half. I need to pick another value of x. Again, I'm trying to make sort of the equations easy. So if I pick x equals 2, I suppose. 2 squared is 4 and 1 is 5, equals a bracket 2 squared is 4 and 2 is 6, plus x is 2, so that's 2b plus c inside the bracket and a 2 outside. So 5 is equal to 6a plus 4b plus 2c. So a is a half, so 5 is equal to 6 halves is 3 plus 4b plus 2c. Stick 3 over, so I got 4b plus 2c equals 2. So there's the two equations I need to solve simultaneously. So if I double the first equation, so 2b plus 2c equals 1. 4b plus 2c equals 2. If I subtract those, take away upwards because the 4 is bigger, so that's 2b equals 1. So b equals a half, and then substitute back in, So a half plus c equals a half, so c is equal to naught. So the answer then is a over x, so x squared plus 1 over x bracket x squared plus 2 is equal to a, which is a half over x, plus bx, that's a half x, plus c is nothing, over x squared plus 1. And that doesn't look very tidy with the fraction on top, so I'll bring that underneath. So that'll be 1 over 2x plus 1 over, sorry, plus 1x plus x over 2 bracket x squared plus 1.